Hello, my name is Adams. In this video, I will explain how linked lists can be used internally to implement stacks and queue, two fundamental data structures. I will also highlight the type complexities of these operations and give real-life scenarios where they apply. First of all, I'll start with stacks with linked list. The stack follows the principle of last in first out. Like a stack of plates in a cafeteria, the last plate that is placed on top is always the first one to be removed. So using a linked list, we can treat the head of the shop as the top of the stack. In operations, we actually use to add an item. We actually use push. So this helps us to insert a new node at the head. In real life example, it is like adding a browser tab to your back history, and it has a big connotation complexity of 01. Then there is a pop, which is actually used to remove an item. You remove it from the head node, and then it has a complexity of 01. And it's the real life scenario is clicking back in a browser, which removes the most recent page. Then there's a pick which is used to there's a get up which is used to pick. So this it helps you to return the value at the head without removing it, just like picking up, just like the word pick. It has a complexity of 01, and the example is like looking at the top plate without actually taking it. So there is a this empty function which is used to check if the head is full. It has a complexity of 01, and then the example is checking if your stack of books is actually empty. Then the second part of it is how queues work with a linked list. A queue follows the principle of first in, first out, like people lining up in a bus station, and the person, the first person in line is the first person to board the bus. Using the linked list, we can treat the head as the front, and then we can treat the tail as the rear. So the operations that are being used there are operations like to add an item using NQ, which inserts a new node at the tail. So it has a complexity of 01. It is like a new passenger joins the line at the bus stop from the back, joins the line from the back. And then there's a DQ, which is being used to remove the item from the head. It has a complexity of 01. And the example is like the first passenger that boards the bus. And then there's the size, which is used to traverse the list or maintain a counter. The complexity is 01 if we are tracking the size, and then it is 0n if we traverse the size. So the example is counting how many people are waiting. There's an is empty, which is used to check if the head is null. The complexity is 01, and then the example is checking if the line is empty. So in summary, stacks and queue can be efficiently implemented using a linked list. Stack models scenarios like browser history or undo operations, while queue models real world lines like customer service or bus stop. Both rely on big connotation 01 operations for insertion removal when implemented with linked list. Thank you so much for watching.